several uses of differentiation at this stage, and we'll start off by looking at how to find the equation of a tangent to a curve. And remember that the skills that we're going to need in this are basic differentiation, and we're also going to need to remember our techniques of finding the equation of a straight line. Because I want to find the tangent to a curve, I have to find its gradient. Remember, how do we find gradient of a curve? We differentiate. So the first thing we need to do then, we take our equation and we're going to differentiate that. So dy by dx equals, differentiate 3x cubed. Remember the rule, the power comes down giving us 3 times 3, which is 9, and you take 1 away from the power, so 3 becomes power 2. Take away, differentiate 2x gives us 2. So this is the gradient of the curve, anywhere on the curve. Now, it's important that you distinguish the gradient anywhere, which is this, from the gradient at the particular point that we're going to look at, which is that. And I shall always do that by using m specifically for the gradient at the point. So very important to remember this. dy by dx is the gradient anywhere. Now I'm going to find the particular gradient when x is equal to -1. So if I put -1 into here, I get 9 times -1 squared, take away 2. -1 squared, of course, is +1, times 9 is 9. Take away 2 gives me the gradient at this point is equal to 7. Now I want to find the equation of the tangent. The tangent is a straight line. What do I know about the straight line? I know it goes through this point here, and I know that its gradient is 7. Now, do you remember the equation that we said was very important when we were looking at equations of straight lines, and I said you'll keep meeting this, so here we go, this is where we're going to meet it again. Y minus y1 equals m times x minus x1. And you can see now, hopefully, why I've used m here for the gradient at this point, because that's what I'm going to put here. So let's put these numbers in. So y, take away y1, which is -1. So that becomes +1, equals m, which is 7, times x, take away x1, which is also -1, so that becomes +1. Multiply out the bracket, 7x plus 7. Take 1 away from each side, we can take this 1 away from each side, and we end up with the final equation, y equals 7x plus 6. So that is the equation of the tangent to this curve at this point.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.